Welcome to our talk today on GemStone 64. Okay. Well, it says power. So, yeah. Well, I can try holding it very close and speaking very loud. We'll see how this does. Okay. I don't think it's me. It's the same. Yes. Okay. Okay, our agenda today, we're going to briefly mention some of the election events just to bring you up to date, and then go into small talk and GemStone. We found that if you look at the second line and the next to last column under popular vote, Hillary Clinton got 47.63 and Donald Trump got 47.30. But in the United States, we have a funny thing called the Electoral College, where the states vote differently than the population votes. And so while Hillary had a 0.3% advantage in the popular vote, and these are incomplete results, Donald Trump got 279 electoral votes, is projected. So a lot, and then there are other third-party candidates. The best performing there was the Libertarian at 3%, but again, based on the Electoral College, no votes. Yes?
We used to have the same system.
Yes?
But we are farther
ahead.
That you
Yes. Okay. Well, we may be learning from the from the people. Yes, Martin. Well, we're coming. So.
That's the same happened with Obama.
Yeah.
I think so, right?
I don't remember if it was with Obama, but I know the Bush-Gore was some disputes about who got the most popular vote versus Electoral College. Anyway, I'm not going to spend a lot of time on this. So it turns out that the website for the Citizenship and Immigration Canada crashed last night during the vote reporting. So Americans, we're starting to research that. Before I left, I told my wife that whether I came back or she came here was going to depend on what happened while I was gone. So, we do have, actually several of us from the States are residents of Oregon. So I'm mentioning this just for those of us, yes, including Andreas. So the GemStone team, or Gem Talk. So Oregon, as expected, re-elected its Democratic governor with 50% of the vote. The Republican got 43%. The Libertarian and Independents each got about 2%. So that's about par for the course for third parties.
So you got
2% is what was there. So the agenda for small talk. I find that in describing GemStone, I often have to start by describing small talk. And many of you are familiar with it, but sometimes we get students coming in, and this is something that they've been invited to. Also, maybe I'll try out my sales pitch on you. You can tell me how you to refine it, or you might try these tactics as well. So I find it interesting to look at the background of small talk and say that it came out of the artificial intelligence community. And it's interesting to look at the optimism and passion that existed for we have big ambitions. In 1958, within 10 years, a digital computer will be the world's chess champion. Okay? In 1965, machines will be capable within 20 years of doing any work a man can do. 1967, Marvin Minsky, one of the outstanding leaders in this field, and these people were brilliant and are. Within a generation, the problem of creating artificial intelligence will be substantially solved. And a few years later in Life magazine, he wrote, in 3 to 8 years, we will have a machine with the general intelligence of an average human being. So at that time, in this environment, people had big ambitions, and they believed that great things were going to be accomplished. Now, of course, we saw how that turned out. But there are people that came from that and were heavily influenced by that. Alan Kay was part of the Stanford AI project in '69. He went to Xerox and in 1972 asserted that you could define the most powerful programming language in the world in a page of code. And that was inspired partly by Lisp. Dan Ingalls built the first version, and Kay presented the ideas to the MIT AI lab. And their ambition was nothing less than augmenting human intelligence, giving us the ability to go with that. Martin's looking quizzical at my dates, I bet. Or some of it. So, meanwhile, there were other things going on outside the AI world. AT&T had Bell Labs, and their vision was we need to control a telephone switching system. And for that, we have certain needs, and those needs don't include solving world hunger or natural language translation. It includes telephone switching. And so Dennis Ritchie was there in the early 70s and was involved in the development of the C programming language, which is, I think, best described as a high-level wrapper for assembly language. It is, of course, a high-level language, but you essentially need to understand the machine in order to use it. And so what we have is numeric types, many numeric types, each of which is based on the size of the storage location. And if you overflow those values, then you get very strange results. So 255 plus 1 is, or I'm sorry, I'm miswriting this. 127 plus 1 is minus 128. Okay, yes. At least I'm thinking more clearly now. On the other hand, there were our programming languages, again, Smalltalk, where the expectation was that the computer was there to serve the programmer rather than the programmer there to serve the computer. And we, of course, numbers are unbounded integers, and you don't worry about size and wrapping and so on. So, what has come since the 70s and 80s? Well, we had these two paths that diverged. The C-type languages went one direction, where our goal is to make things easy for the computer, and we'll expend human effort to do that. And the other was, we'll expect the computer to make things easy for the human. Now, that idea was a very nice idea, but at the time, the hardware just wasn't there for it. And so there's reasons why natural language processing and solving, becoming chess champions did not happen in the 70s and 80s. And Smalltalk was legitimately criticized as performance problems and not really there. But hardware, I believe, has caught up, and we now have a situation where the cost of computers is much less than the cost of programmers. And the time involved, if you can reduce the development time by 75%, then you might get a lot more done, even if you have to double the number of cores or CPUs that you're applying to the problem. So we now have a scenario where the Smalltalk features are starting to be added back to the more traditional languages. So first garbage collection, then dynamic typing, closures, and we're kind of drifting back into it. But because those paths diverged early on, we have some strangeness that people experience when they come to the small talk world. And Dr. Johnson mentioned the image this morning, which is something that if you start out in this world, then it seems very natural. But if you come to it from the text files world, then it seems very foreign. One example that strikes me is the assignment operator. Just seems very reasonable that you would not want to use equals. You would want to be able to distinguish the single equals from an assignment and the Boolean comparison from an assignment. But that isn't the way C did it, and so the idea of colon equals or from Squeak, the left arrow, is something that just seems very strange. And so the languages that are imitating Smalltalk don't bring in some of these things. Another thing is class names. Most of the environments and libraries that are imitating Smalltalk will use something called a map rather than a dictionary. And there's a series of names that, again, seem a little confusing to those who are not from this world. And, why couldn't you have picked the thing that everybody else used? It's kind of, well, why couldn't they have picked the things we used? But they didn't. So, GemStone, what is this GemStone thing? Well, Smalltalk has some limitations for those of us who have used it. The object space is limited to one virtual machine. It's limited to one host. The object space is limited to available RAM. And finally, the objects that have changed since your last snapshot of the object space are lost when the virtual machine exits. And these are disadvantages. But in the magical world of GemStone, object space is visible to thousands of virtual machines on hundreds or thousands of hardware hosts. The object space is limited by disk, not by RAM. Object change is managed through ACID semantics. ACID being the acronym database people use for atomic, consistent, isolated, and durable. So that gives us this database semantics with a distributed image. Object changes are guaranteed persistent once committed. So if the image crashes or your system crashes, you haven't lost anything. Scalability is there, billions of objects, thousands of users, machines, transactions per second, and terabytes of data. So these are the things that we have for scalability. Key features for GemStone: concurrency. We allow multiple sessions to access the same object space. There's the transaction semantics with commit and abort, so you have a consistent view of the database. You can use optimistic locking, and there's some reduced conflicts classes that help with that. You can also use pessimistic locking, where you have object-level read-write locks, so you can do that. Namespaces, you can create namespaces in GemStone that are either shared or private. GemStone has security, object-level security, user, group, world, read or write permissions. Login security with the traditional user ID and password that databases are expected to have. We have, coming soon, a single sign-on that allows, once you're logged into the operating system, you can log into the database without repeating your password. LDAP, PAM, these things, if you are interested in login security, you'll be familiar with them. We can specify per user certain privileges. Which users have the right to initiate database backup, changing passwords, doing garbage collection system-wide, and so on. So in spite of this being a database, it is still 100% Smalltalk. All objects, all the time, classes, methods, blocks, are all objects. ANSI Smalltalk, as we're attempting to maintain compatibility there as much as we can, and as far as we know, we are. We support very large collections. So again, one of the characteristics of a database is large collections. Millions of objects, tens of millions. There's optimizations for searching, so built-in automatically maintained B-tree indexes. So once you create an index on a collection, and if you modify an object, then the index will be automatically updated. So we have our own write barriers that trigger index maintenance. You don't have to maintain the indexes. That's done for you. We have some interfaces to other Smalltalks. VisualWorks, the Syncom Smalltalk, is extensively used by many of our customers. We have GemBuilder for VisualWorks. VA Smalltalk, formerly from IBM, is being used by probably the other large segment of our customers. GemBuilder for VA provides a library that you can load into your client Smalltalk and manage transparent replication. These are what most of our traditional clients are doing with client-server technology. We also have been providing Pharo with some open source pieces, and Dale will be talking more about that. But it's not the complete, pure, invisible, automatic object replication, but there are ways of working together. We have interfaces to other languages, C, C++. There's a DLL for Windows and the shared libraries for the Unix, .so for the Macintosh. Java has a library, a jar file that you can load in and interact with the database from Java. We have interfaces to relational databases, both Oracle as a commercial product and Sybase is an open source one. We have released 3.3.1 is our latest release that came out this summer, and 3.3.2 will be out sometime in the next few weeks, I believe. The next major release of 3.4 will be coming next year. At one time we were saying spring. These things always tend to drift, but I hope it's by ESUG. So what were some of the new things that got put in? And a lot of these are going to be a little bit more technical details. And since sessions have been running a bit long, I'm going to go through these fairly quickly because I don't know that unless you're actually currently using GemStone, which we do have a few users here, our friends from Telecom and Mercap and JP Morgan are using GemStone. Smalltalk virtual machine performance, native code generation, branch prediction, math performance, especially integer math. We have some of the financial services people who are pushing us on integer math. Depending on the functionality, we feel like it's about 25% faster than the 3.2 version. We have more performance on Translog Restore, about a 30% improvement. So if you're restoring Tranlogs, that will help. Small fraction is trying to keep your interest during the technical details. Small fraction is now an immediate object. So like small integer, it is included in the object ID. So you don't have to go out to read it. And so it's guaranteed canonical with numerator range and denominator range. So that helps our compacting and performance. GS file improvement, native UTF-8 and more primitives, again, faster interaction with the file system. LZ4 data compression, this is a new compression algorithm that can go faster than zlib, and which is the thing underlying gzip. The compression ratio is slightly worse, but the performance improvement is typically worth it. And so we're looking to use it for, we are using it for communication between hosts so that we can interact more quickly. Encryption. Some of our customers are saying we want the data encrypted on the network. So we're providing more in the way of options for encryption as we're communicating between Gem and page server. One of the things we recommend to our customers is that they run some monitoring tools. There's a statistical gathering application that goes with the product. And that now can be configured to start automatically whenever the database is starting. Page audit is something that is often part of good hygiene for database management, and that is now multi-threaded and can be up to 20 times faster. We worked with one of our customers to do a canonicalization framework. And so this allows you to keep objects that are likely to be shared canonicalized. So there's typically only one of them, and that reduces the object count. So things like dates, where in a 100-year period you should only have about 36,000 dates. But if you have purchase orders, 1 million purchase orders, then you might have 1 million dates in it. So that's something to worry about. Page servers are now faster. One process for one remote gem is the old process. Now we have one page server that is started for all the gems on a remote host, and we use threads rather than processes. So that rather than the process of having a separate page server for each gem, we now have a single page server with threads that handle each of this. So this reduces the overhead on the operating system at the Stone host. You can warm the cache. This is starting up the database more quickly, getting data into memory, advantageous for distributed systems. We have a cloud architecture where you can actually have machines distributed over a slow network, wide area network. We had a customer discussing a desire to run the primary database in Europe and have the same database instances of it running in North America, so across the Atlantic. And so that is a slow wide area network, and for that there's various caching processes that got put in place. We have a GemBuilder for Android. This is kind of an experimental project, but if you'd like to run on an Android device, here is a test application where you enter an IP address, a port, Stone name, user ID, password, click Login, and now you can enter Smalltalk and execute it and see the results. So if you're interested in that, the code is available and there's some contact information. And, again, we're trying to explore some ideas, but not sure what people will find necessary or useful. Our statistical tool is faster load times and more columns sorting capabilities. And we currently support, in this version, Linux, Apple, Oracle Solaris on AMD hardware, and Oracle Solaris on SPARC hardware. And finally, the IBM AIX PowerPC. So we've got 5 server platforms, and we have client libraries for these 5 plus Windows. So those are available as well. GBS is available for Syncom's Smalltalk, VisualWorks, in supporting 7.10 and 8.1. and is available on 4 platforms. Instantiations, VA Smalltalk, version 8.6 we support with Microsoft Windows 32-bit. So I'm going to take just a couple more minutes and describe the things that are coming. We have LZ4 support for more of the files that are in use. Encryption of backups and tranlogs. So some of our DBAs say we need encrypted, whenever it's on disk, it should be encrypted if it's a backup or tranlog, because those tend to hang around in the file system. OpenSSL 1.1 is still in beta, but once 1.1 is final, we'll be incorporating that into what we're doing. Find reference paths is a useful tool to figure out where is this object being referenced? What is the path from the root object to keep it from being garbage collected? We're working on, Dale's primarily working on Git support in the base image with the Cypress project. And so to help load things in a more portable fashion. Single sign-on, as we mentioned, is coming in 3.4 with various options. And finally, we have some licensing choices. We are, again, a commercial product. You can buy once and get a perpetual license. You can go with an annual subscription, pay just each year. And we have also a value-added resellers program for those who are building applications that they're selling to others, where instead of licensing it at the database price, you incorporate it into your product and give us a percentage of the royalties. We also have a community edition. So although we are a commercial vendor, we are trying to help people get started and incubate some of the low-end opportunities. So we ship with the product a perpetual license that is continually effective for that version. Cores, 2 cores, 1 gig shared page cache, 10 gems, 10 gig disk. You can run 1 production database and unlimited development ones. And from there we go up by adding shared page cache and or cores and or gems and disks, where there is an option where, again, is free. The first 2 columns are free. The first one is shipped with the product, and the second one, all you need to do is send an email, and we'll provide you with a key file that has the additional. From there, you can see the information, and that is available on our website. We participate in STIC, ESUG. We're one of the sponsors here of FAST. We participate in the Faro Consortium, various open source projects, and that gives me 28 minutes. So if you have some questions, otherwise we'll take a break. Okay, I'll be around. Martin is here, Dale is here, so ask us about GemStone. This is our passion, and we came this far. Yeah. Yes. Okay. Or just a stretch, huh?
Well, you can repeat it. I know you used to release the community edition as a virtual machine. Is that the way to access it?
No, we do not have. We're not releasing the community edition as a virtual machine. And it's not that we're not willing to. And there is, it's just whenever we did, it needs to be updated, and there's a certain amount of, there's only so much we can do to make it easy to run GemStone. And if you're going to be running a Linux environment, then you probably know how to install software in that Linux environment. Dale?
Well, if you're going to do that, there is an open source project. it provides a bunch of scripts
Yes.
for installing GemStone on a machine and then running and controlling all the stones on that machine. So start stone, create stone, creating clients. This is part of a code environment.
Yes. Yeah, we're not leaving you completely to your own devices for doing this. There are many scripts. We're attempting to make it fairly straightforward to do it, but we are no longer shipping a virtual image. Now, if you're running on the Macintosh, we do have an off-the-books goodie that is supposed to make it sort of, if you're a Unix Linux person, then you can use the scripting environment and the tools. Dale?
GbjTest works on Mac.
Okay.
And Linux box.
Yes.
And
Okay.
Of course, Windows clients.
Yes. Okay. So the GS Dev Kit Home is the place to go for access to installing and running backup tools. All the administrative things are there through a user interface. But it's not a virtual machine. Okay, time for our break.
Yes, let's try to debug, sorry to debug at 6:15. Very well, it has 6:16.
You were giggling at some of it.
Oh, yes.